Start recording. Okay. Hello, everyone, and welcome to Handmade Hero, the show where we code an entire game from scratch using nothing but our bare fingers, never toes, no engines, no libraries, no nothing. It's from scratch here on Handmade Hero. That's the way we do it, and that is the way we have done it since day one. No reason to stop now. If you are one of those fine individuals who has pre-ordered the game on handmadehero.org, you can go to the link that you got in your email and download the source code anytime you want. That link keeps on working. It's the gift that keeps on giving, frankly. And so if you want to follow along with today's stream and you do not know how to do that and you're just like, what's going on here? It's really simple. All you got to do is extract the day 47 zip. This one, we're on 48. We're on day 48 right now. So extract that day 47 zip into a directory, and then also unzip the, if you want to use our the assets that come with it, that's a separate zip file you could download and unzip into the data directory. And that'll allow you to be like exactly where we are right now. So you can follow along with everything I do at home. It's kind of like one of those shows on PBS where, you know, the guy paints and you're supposed to paint along with him. And you have no idea like why he's, you know, what he's doing exactly, but then it turns out to be some kind of weird cherry tree at the end or something, right? And it's fine. All right, so without further ado, let's get back to where we were yesterday, which was very deflating because I was just about to finish some code and we had to end the stream because the stream was over. So let's take a look at what was going on there. If you remember, we had our little dude here, right? And we were about to do some collision work with him, and we wanted to be able to have him run into the walls properly. You can see he sticks on the walls right now, and so what we need to do is we need to fix that. We wanted to make a good collision thing so that we'd be kind of all set to go. All right, so how do we do that? Well, we started writing something. I was sort of teaching collision detection in baby steps. And so we were going down each individual baby step, and we got to the baby step of how to test against just simple walls. So just a point, like a moving point versus one horizontal or vertical wall. And we wrote the equations for that, and we solved them, and then we didn't quite get a chance to actually ever write the loop. So that's what we're doing today. All we got to do is write that loop, and then at least we can have some decent collision. Now, we've got other stuff that we want to do after that to make our collision detection a lot better, but that's the first thing that we need to do just as our baby step before we can really talk about what to do to make it better. So let's do that, because right now, frankly, the collision in this engine is awful. Well, we don't really have an engine, but the collision in this app is awful. And it shouldn't be awful, it should be good. So here we go. What we have decided to do is take the place where the player was and the place where the player will be if he is unobstructed. So the 2 points, where he's going from, where he's going to. We have figured out all of the tiles that would be involved if we just made a rectangle using that span, basically. We're going to walk through each of those tiles, and if any of those tiles has a wall, like if it's marked as solid, then we are going to test against all 4 of the walls. We're then going to take whatever the soonest collision would be with one of those walls and keep that as the earliest collision point. That will tell us where our player will stop, if he's going to stop. Now, we've pre-initialized the minimum intersection time, 1.0, which is basically all the way to the new position. 0 would be standing where we are. 1.0 would be all the way to the new location, right? We've pre-initialized it to 1.0 so that every time through the loop, when we check to see whether we've gotten a better collision than what we had before, if it's ever above 1.0, meaning it would be past where we would actually want to end if the guy could move all the way to where he wanted to be, we just won't even consider it. So that kind of already takes care of all the collision stuff that would be past the place where we would end. Because obviously we don't care about collisions that happen after we get to where we were already going. And again, we'll still, our solution, when we do our solves, we'll still get those things that are off there because we're figuring out the time, we're doing a solve for the time at which you would collide, and that time is not bounded by anything. So it could say, oh, in 10 minutes, you'll end up down and hitting this wall. And it's like, well, great, thanks, but we're not gonna, we're not trying to take a 10-minute time step. So that's how those things get eliminated, is by setting this team into 1.0, which is the full motion that can happen. All right, so what we do here is we first start out by saying we're going to do each individual collision detection from the perspective of the tile that we are checking. So we take the tile that we're checking and we subtract away the player position, right, from that tile. So we can actually do it in one of two ways. We can do it where we have the player is we can have the vector going from where the player is how should I say this? We can have the where the player is be relative to the tile, or we can have the tile be relative to the player. And I think what we want to do here in this case is just make it so that the player is relative to the tile. So we're taking the tile center and we're talking about the position of the player relative to the tile center. So basically the relative thing for that is going to be, we'd want to do it this way. We'd want to subtract the tile position, right? We'd want to subtract the tile position from the player position, which would give us a vector from the center of the tile out to where the player is, okay? We then also have this, the player delta vector, which is pointing in the direction of travel. And that player delta vector is exactly as long as the total distance we want to travel to check. Basically, the entire move we would do this time step if we weren't obstructed. So we go ahead and say, okay, we get that relative new player P, that's relative to the center of the tile. And now we have the locations of the walls relative to the center of the tile as well, min corner, max corner, right? So now what we need to do is test all 4 walls and take whatever the minimum z is. So let's just test one wall for starters, right? And I guess I've already kind of started with that here, right? I said test wall, and I was going to pass the various parameters for it. So what I need to do is I need to write a function that'll basically update this for each wall so that we can test the 4 different walls of a tile. So I'm going to write it in place first for one wall, and then I'll pull it out into a function we can call once for each wall so that we don't have to type the same code 4 times, right? Assuming that I can. We'll see, you know, maybe it's too hard to pull out and we'll make a macro, who knows, we'll see. Okay, this should be minimum t. I don't know where z came from there. Okay, so here was our equation. Our t result, meaning the t along that, the percentage along the player delta vector that we would have to go to intersect a particular wall's x-coordinate at an x-coordinate. So a wall at an x-coordinate, remember, is a vertical wall, right? So at the x-coordinate of the wall we care about, right, we want to subtract whatever the player's x-coordinate is, and then we want to divide by whatever the delta x-coordinate is, so the x offset. That will give us the t at which we would arrive there. We then want to check the bounds of that thing. And in order to check the bounds of that thing, we then have to figure out where the other component would be, right? So where would the y be, right? Well, we know where the y would be. The y is just going to be that t result, whatever that t result is, however far the t result was, right? It's just going to be that times that player delta vector is y, right? Because remember, I can do an entire vector, t result times the vector equals how far along that vector I've gone. And in this case, I only care about the y, so I'm just going to use the y component of it and save myself the trouble, right? It's going to be that's how far he would move along that t. And we've got the new player's x-coordinate here. I'm sorry, the new player's y-coordinate here, right? So we can go ahead and, how did I just do that? So we can go ahead and add that, and this is how far he would have gotten total, right? The new y-coordinate is going to be his old y-coordinate. And what? You know what? Why is this new player P? That's not right at all. That should be old. We wanted where he started from. It's old player P. I don't know why this is... Why is that new? Who did that? Who snuck in here? I'm sure, obviously, it could not have been me. Somebody has been into the code base and put in the wrong variable. How dare they? Those people will be found and severely chastised. All right. So here we go. We solve for that t result. We find out what the new y is, and now we just need to see whether that y is within the bounds that would be valid for this wall, because the wall is not infinite. It's between, you know, 2 things. So we want to say basically that if that new y is greater than or equal to the min corners y, right? Then it's definitely above the minimum bound, and if the y is less than or equal to the max corners y, then it's within that maximum bound of the tile. I don't know what this test wall is doing there. So if it's in there, then this is actually valid. And if it's valid, then what we want to do is check that t-min. So we want to say if t-min is greater than t-result, then that means this is a closer collision than we've had before, right? Excuse me. And you know, we could check this first since it's a simpler test. If that t-min is greater than t-result, then that means that the t result is a closer collision, and so we should accept it, right? So we should accept it, and well, sorry, we should accept it assuming that the wall exists at that point, right? So that's really all we need to do, but there's a catch, and I talked about it on the last stream. Don't know if you remember. What's missing here? Does anyone remember what's missing? Remember what's missing. Remember. Okay, I'm just going to assume that you remembered, and the stream is right now filled with people saying the thing that you are all remembering. When we do this computation for t result, right, we are going to get the intersection of essentially the whole line that the player is traveling along with that wall, which means he could go backwards and hit the wall, which we don't care about. So what we want to do is also say, well, t result has to be greater than 0 to begin with, right? If t result is not greater than 0 to begin with, then we're not gonna count this as a collision, because that means the guy had to go backwards in order to hit it, and we're not going backwards, so that doesn't count. So we're strictly interested in collisions between 0 and 1. That's where we want to be. And so so that's what we're checking for. So assuming that we got that, we will then stop. So which wall did we collide against here, right? Well, so if we took wall X to be, oops, it's not accidentally hit page up. If we were assuming that we were going to test against, let's say, our max corner X, right? So max corner X testing would basically give us, excuse me, got an itch, would basically mean that we can test against the right wall of anything, right? So that's good. We could go test that afterwards. All right, so now we have one more thing, and I don't know if when I said what's missing, you guys remembered this as well. So I'm just going to come out with it. We again harped on it yesterday. This guy right here, what's going on with this guy, right? What is the deal here, people? This might be small. It might be so small, in fact, it could be 0. And what would happen if we were to divide by a very small number or 0? We would get a disastrous result. 0, of course, would cause the FPU to actually put like an invalid value in there. Or if we divide by a very, very, very small number, this will end up being huge. That's not such a big deal because it'll immediately get thrashed by this. But basically, we got to make sure this guy isn't 0 at the very least, right? So we got to check to make sure that player X is not equal to 0, because if it's equal to 0, it's bad news bears. Now, fortunately, if I were the sort of person who ever remembered all the weird rules for like what happens when the SSE registers when you divide by 0, it's possible that this is one of those routines where it would just work, right? Because if you could guarantee that t result would always be greater than 1 in the case where this was 0, we'd actually be fine, right? Because this check would nullify it. But I don't know, right? So I'm not going to leave that to chance at the moment. And if we really care about it down the road when we're doing optimizations, we will go read the manual and figure out whether this is a safe divide by 0 zone where we could like turn off divide by 0 exception and just let stuff rock out. You know what I'm saying? Like one of those concerts where everyone gets backstage. You know the ones I'm talking about. Anyway, so basically, that is all we really need to do to test against one wall, modulo bugs that I may have coded in there while I was yakking. So in theory, we should be able to test against one wall now while we are moving around. So I guess we're only testing against this wall. And so, oh, you know what I just realized though? We're going to have to actually enable this case, which we didn't yet. That's what we actually wanted to do. There we go. Okay. So we got some compiler errors. X is not a member of tile map difference. That is actually true. So that's its rel. That's what I wanted, rel. I already made that into a v2. There we go. So no, who knows what will happen now? Okay, so we're not in good shape. It's true. Oh, well, that's just because I forgot to actually move the dude. Sorry, dude. I forgot to actually move him in the case where, you know, because basically what happens here, right, is we set these sorts of things like whether you collided and that sort of stuff, right? And then we did some updating stuff here depending on the situation and all that sort of stuff. So what we got to do here, I don't even know what was this even supposed to be. If call p abs tile x is less than entity p abs tile x, r equals, and so then what did we do with the r? We just, okay, so this was basically, this was our wall. This reset the velocity. So we're going to have to do something similar to that with the velocity. But for right now, we don't really care too much about that. So we'll do that in a second. But this is basically the problem that we need to solve right here. We need entity P equals new player P, and we haven't done that yet. So basically what we need to do is we need to actually make our new player P.offset code. We want that to actually, yeah, we don't even want that to be happening the way that it's happening up here, really. This is all kind of not good. We're just gonna, you know what we're gonna do? This is what we're gonna do. We're gonna move all this cruft into here, and then we're gonna say, all right, this is the actual stuff that we actually want. So we've got our player delta, that can be computed stably. And then what we want to do is say, okay, when we actually have the player delta, we need to recompute the velocity still, which is this guy here. But we don't really know what's going to happen to that exactly. I guess we kind of do. We could do that. So it depends. We have to talk about the order of operations there a little later when we're finessing this. But that's mostly right. And so what we want to do now is actually move this stuff down there. So we've got our player delta, and we've got that stuff computed. But now, in this case, what we're going to do is we're actually going to go ahead and do that update in a slightly different way. Instead of doing it the way we were doing it before, we're now going to multiply that delta vector by whatever our minimum intersection was. And so that way, if we hit something, we will only go as far as the thing we hit, because that t-min will have been set to whatever that closest thing we hit was in here. And if nothing gets hit, then we'll just use 1.0, which will step us all the way there, right? Which is what we wanted. So basically, that's it. And then I can do the actual update move, which is here. And we'll just have to deal with velocity in a second once we're ready for that. Okay. So we've got new player P, abs tile X being a complaint here. That's because this is all, oh, okay, that's, all right. So never mind. I guess I did need new player P. I guess I did need new player P because I need to actually test against that abs tile X. I apologize, new player P. I guess I thought ahead more than I thought I was. Well, maybe I didn't. I could have just done that by accident. I don't actually know that past Casey was smarter than future Casey in this particular case. All right, so we've got new player P, and it's actually there we go. It's actually being computed there, and now down here I just have to basically redo this a different way, right? I just have to redo it to be the new way. All right, so at least it can still move, so we know that our t-min equals 1 when we don't hit anything is working. So let's see what happens when we go here. Perfect. That's actually exactly right. And we should be able to walk straight on through this wall, right? Yeah. That's hilarious. I can't get back in because there's walls on that side. Oh no, my guy is trapped in the wilderness. Help him. Oh, awful. All right, well, that was a mistake. I admit that. So that's exactly what we're supposed to do. Let me rerun it again because I wanted to show you one thing first, just so we were all clear on it. So you'll notice that he is able to interpenetrate the wall now, and that's because we're only checking his one base point, right? This is a point versus, well, it's a line, but it's the motion of a point versus a wall. So we're only checking that one point that's his sort of base point, right? So you can see that. So he interpenetrates. So one of the things that we're going to do is expand him to an area shape in a bit, so that we can collide against that. But for now, I just wanted to point out that that's why that's happening, just so everyone understood what's going on there. And like, don't do this. Don't ever do that. Do not walk out of there until we implement the other one, or we're in trouble. We could do this with impunity, probably. Can we? No, we didn't. That didn't work very well either. That just got. I'm totally stuck now. Yeah. So we got to go ahead and fix all the rest of this stuff because we're bad news here. If we don't put the rest of these walls in, we're gonna have guys ending up stuck in things all over the place. All right. So all we really need to do now is turn this into something that tests all the walls. So I'm just going to pull this out into a function and see if I can just functionalize it, right? So I'm just going to go ahead and say, all right, I've got this guy here. It's going to be test wall. I'm going to call it. It's going to do this stuff, and we're going to see what we can do in terms of making this usable. So let's assume that I pass. Did I leave? I left it all in there, right? Yeah, good. So basically, we want to pass the wall X, right? In this case, it could be an X or a Y. We want to pass the player delta X, right? And these are actually just going to be like wall, I guess wall X, player delta X. We'll just leave them like that. Player delta X. This will be the rel X, so we got to pass the rel X as well. And then we got that. And then we need the player delta y as well. There we go. And notice we're not passing this as a vector. There's a very good reason for that. In fact, I'll put rel here first. The reason for that, of course, is because we don't actually know if these are x's and y's. They could be inverted because, well, you'll see in a second. Because we want to call it for both ways. We want to call it for y intersections and x intersections, right? Okay, and so then I've got my rel y as well, right? Rel y. And again, I don't know which sense those are. Then I got my t results, my t min. So then we got a t min is the thing we're updating. And then we got our min y and our max y, right? So we got our min y and our max y. Okay, and that'll do the wall test. So what is the problem here? T min needs it. There we go. So that can be updated. And so now I just need to call this, right? I just need to call this with the same things I was calling it with before. So in this case, I call it with wall x, and that's going to be max corner x. There we go. I've got my rel x and my rel y, and then I've got the player delta x and the player delta y, right? And then I've got my t min, and I've got my min corner y and my max corner y, right? And that is my test. There it is. Now what I can do is I can just spam this, right? I can spam this out and say, all right, let's test the other ones. So now let's test the min corner x as well, right? And to do that, all I have to do really is change this, because it's the exact same test, it's just against a different coordinate. And then if I want to test the y, right, all I have to do is pass that and flip the things that I was passing, right? I just flip them, because it can just basically do them in the opposite way that it was doing before. And that should test against all the walls of the thing, if I'm not mistaken. Could be mistaken. Who knows? We'll find out in a second, won't we? So there we go. That hit that wall. That hit that wall. That hit that wall. Oh! I spoke too soon. We are missing a wall. Which wall are we missing, people? So we're missing the y max wall. So there was a typo somewhere there. That would be max corner dot y, rel x, rel y, player delta x, player delta, right? Min corner x, max corner x at t min. What did I type in wrong there? I made a mistake of some kind, but I don't know what it actually was. Well, you know, I actually don't necessarily know that I made a mistake yet, because technically there's something that we haven't quite done. It's a separate issue, but I guess I don't know for sure. Let's put it that way. So let me double check and make sure that that's not the case. What I'm going to do right here is just check to make sure that I don't have a thing where I'm just stepping through the wall, because we're not actually doing anything to prevent that at the moment. Yeah, so that's what I thought. All right, so that's fine. So let's talk about that. All right, so we've gotten to the place where we're successfully testing all the walls, but now we have to deal with problem number 2 for this kind of test, which is that when we actually do this computation, right? So here's the problem that we have. When we actually do this, we are finding the point where he exactly hits the wall, where this guy exactly hits the wall, right? And we have a problem, which is that if we then allow him to actually be there, on the next time step, he won't actually necessarily, you know, due to precision issues and so on, he won't necessarily ever hit this wall, because he might be just a little bit to the other side of it, right? Because we're counting on that equation producing a t that is greater than or equal to 0, right? But if we move him right up to the wall and stick him right on it, if we stick him even the smallest fraction of a floating point value to the other side of it, right, then he would not actually, that test would no longer succeed. So we don't have a very big margin for error there, and that's not a good thing, right? That's not a good thing at all, because that's just not how you want to roll, right? So there's a number of ways that we could deal with this, and it's unclear exactly necessarily what we want them to be. I'd have to think about this a little bit more to think about what I ultimately want to do. For right now, since we're only doing a very simple thing, I would say that the easiest thing to do is just for us to make sure that we put him a little bit back from the wall always if he hits the wall, right? Just make sure that you're a little bit back from it. That's probably the easiest thing to do and wouldn't really cause any problems. But basically, yeah, this is something that we probably want to handle more robustly. Once we get forward enough that we've actually written collision detection the way that we want to do it with area shapes and so on, then we'll talk a little bit more about this case again and see if we can't do a cleaner job. But for right now, I'm going to do is make sure that he's back a little bit from it, right? So what I want to do there is say that whenever he hits a wall, right, whenever he actually hits a wall there, I would like him essentially to be just a bit back from it. So when he does that, I'm going to say that we're going to have this little, like, we're going to have some kind of an epsilon on the T. It'd be nice if that was in world space and not motion space, though, is the only thing. Because if I do it in the terms of the T value, then the problem with that is that's going to be proportional to how far he moved. I'll see if this works for now. Like I said, I don't want to necessarily do it quite this way when we get to the end, so I'm not going to sweat it too much making this quite right, because I'm not sure that we really care, but, you know, we'll see. So I'm going to make a little epsilon here, right? That epsilon is just typically a term we use for like a very small value that we're using to make a tolerance to work around floating point things. I'm just going to say that the T epsilon is going to be something like, you know, 0.01 or something like that. I don't know yet. But we'll just have some arbitrary value that we stick in there. And we'll basically say, okay, in the case where we actually hit the T min, what we're going to do is say we'll give it the minimum of that and that T result minus that epsilon distance, right? And again, this is not a particularly good way to handle this, I don't think. But I just want to see if this will fix our situation, right? Let's see here. Yeah. So you can see it's not really great, but, you know, and it is a little further away than I would like. You can see it's pretty far, actually, from where the guy is, if that makes sense. Yeah. So, all right. So we want that to be much smaller, maybe something like this. I don't know why I keep closing the application. So now we can go right up to the wall and hit it. I don't know why that was a little weird. I don't know why he's hitting it that way. That's very strange. I gotta take a look at why that's happening. Feels like his velocity is much larger than I would think, or his delta is much larger than I would think it would be. That is very strange. Yes, that's fine. Continue. Oh, that's right. We don't actually have a way to continue beyond that. So anyway, yeah, I don't love that. Let's go ahead and take a look at this some more. Because that's not quite as good as I would have liked it to be, just in general. But anyway, that's what happens when he hits the wall. We now at least know when he hits the wall, and we just have we don't have a very robust algorithm right now in terms of dealing with what happens when we actually want the floating point stuff to work out properly. Oh, you know what we forgot to do though? I know what we forgot to do. We need to do our recanonicalize. That's something that we need to actually go look at as well pretty soon here, because that's going to get annoying real fast, since we haven't gotten to that point yet. Yeah. So I believe we won't hit that assertion now that we're doing our recanonicalize, but we still just have that nasty. I feel like that should stop right at the edge, and it isn't. So I wonder if I have another bug. I feel like I must have another bug there. That just feels really wrong to me. So I think there's a bug. I don't know why. Why do I keep closing the app? I'm used to today. I was working on stuff all day that did not have dynamic reloading because I'm working on some lower level stuff. And so I'm used to having to close the app every time I'm going to rerun it. So I feel like there's something incorrect in what I'm doing that's causing me to get that stoppage in a way that I don't like. And so I'm going to take another look again here at this and say, what exactly is going on? Okay, that's funny. I typed minimum instead of maximum. Not the brightest move in the book. Yeah. So I was trying to clamp against 0 because I didn't want it to make it move backwards. And I typed minimum, which meant it was always going to pick 0. Oh, that's awful. I don't know if that's owl of shame awful, but it's pretty dumb. There we go. That's much better. Yeah. So now we're back to where I thought we should be, which is being able to hit exactly. Now, I don't know why we're getting that. I wonder if I'm still not doing the recanonicalize properly. Let's take a look here. So tile, I might still not be doing that right, but let me look at what tile rel is here. So tile relative is really large, so that seems wrong. So I think we're not doing that properly. New player P, recanonicalize position. So why are we getting that? What's the tile side in meters? Tile map, tile side in meters. 1.3. Well, no, that's about even though. That's pretty darn close, right? That's about right, I would say. So, yeah, that's probably close enough. These guys, yeah, these guys are just gonna have to. That's just the way that's gonna go, basically. Yeah, I don't think there's much of a way around that necessarily. Let's see here. I wonder if those should be loosened. Handmade tile. That's what you see. So remember, we put these in just to check when we were doing recons. We know that they're not going to be exact at the moment. So I'm wondering what's happening here. When we do this offset and we subtract after we do the divide, I'm wondering why it's unable to get us to half properly like that. Let's see here. You know, should I allow some slop there? Yeah. We'll see. Because yeah, I don't know exactly what we want to do about that. But I don't love having those kind of. I don't like any kind of epsilon things really. So usually once we have an epsilon in the code, I usually kind of think of it as something that I want to go back and fix, but only once I actually know that I'm going to use the code. So like that looked like he went a little bit too far into there, which also looked a little bit janky. I want to see if I can reproduce that. I don't know if I can, though. Yeah. So how did he get in there? I'm assuming that that is us not checking something the way that we should be checking, right? Because he shouldn't ever be able to move in like that, right? Like you can see, he can get through there, right? So how did he manage to do that? How did he sneak through that hole? I would like to know. So yeah, you can see that. All right, so I think basically probably the easiest thing to do would just be to step up to the next level of collision detection rather than trying to get this to work more seamlessly, because most of the things that we're seeing here that are janky are things that will go away if we move to the next sort of level of goodness, if that makes sense. So let's just call that done for now, but observe the problems, right? The problems are we have to have an epsilon in order to not go through the wall. And even with that epsilon, I believe, and I can't say for sure because you know what we could do? We could actually do something to visualize this to make it a little easier to see what I think is happening there. And I just want to make sure everyone can see all the problems with it before we go up to the next thing. Let's see here. I want to render these guys a little smaller than they would otherwise be. So like that, I think. So there we go. So did you see that? Basically what happened there? That is exactly what I'm talking about. So I can't get through here, but if I could hit it directly at the edge, right? Where is it? Come on, there we go. Right, did you see that? If I hit it directly at the edge, I can get in between where I was hitting this wall and this wall, right? These two neighboring walls, the two vertical walls, I can just manage to get between it, right? And I think someone on the stream the other day was asking about how you can glitch through walls, and I sort of drew that case where the things were just a little bit off. So that's an example, right? Because numerically it's just not stable enough. So there's a gap essentially that you can sort of fit through there if you kind of work at it, right? So that's a good example. So, all right. So we've got a bunch of things that we would like to do now. And basically what they boil down to, there's really two totally separate things that we want that both come from the same, that will both be solved by the same solution, if that makes sense. So what are they? All right. Oops, that's no good. Okay. So the first thing is that we are testing against an infinitely thin wall, right? We're testing against something that's like this little tiny thin wall, and all we know about is that pinpoint in space that the wall is. And what that means is that if the guy is on this side of the wall, he can hit it going this way. And if the guy's on this side of the wall, he can hit it going that way. But if he's right here or right here, right? Remember, imagine this was very, very microscopic. So he's just a hair on either side, right? He would still be able to move freely in that direction or freely in that direction, right? So if we're ever off by even the slightest bit numerically, and we thought we were stopping him right here, but we actually put him just on the other side, right? It'll allow the player to tunnel right through the wall. And that's a symptom of the fact that we're treating it as just this thin, right, this very infinitely thin wall. You know what I'm saying? So that's not very good. We don't like that. What we would rather be the case is we'd rather it be the case that this were a solid thing, right? Something that didn't have a very tiny little minuscule sort of thing to it where numerical imprecision could ever happen. We would want this to be as thick, some thickness that allowed it to not get through. And of course, if we think about it, the tile itself, right, is very much a solid thing. So like the fact that we were testing against each wall individually and treating it as infinitely thin isn't really necessary, because the thing that we're trying to simulate is not even an infinitely thin border around something, right? We're actually okay with just saying, hey, you can't walk anywhere within this entire block, right? So what we'd like to do is solve this problem, first of all. But then we have another problem that we also have, right? And that problem is that our guy is too tiny in his collision sense right now, right? He can interpenetrate here because we're only doing collision detection with that point, right? And the reason that we're only doing collision detection with the point is because all we know how to do at this point is do collision detection along a ray, right? So we have a ray that he's moving along, and we're testing that against the wall, but really he should be some shape here, He should be like a circle or something, so that when he moves when he's collision detecting against other things, it's actually whenever any part of the circle would touch the thing that he's colliding against that we'd stop him. And that would allow us to give him some volume, right? So that he stops away from the wall like, there properly, but also if he's going in the other direction, stops away from the wall, like there or whatever, right? So something that gives him that volume back. And I think that's obviously something that we want as well. And so both of those things are basically sort of asking us to move up a level in complexity of how we're doing our collision detection and say, instead of talking just about lines, right? Because all we were talking about is lines. Basically what we wrote before was something that intersects the line of the player, right, with the line of the world, some kind of line in the world. So what we're talking about now is we're saying, let's move from lines to testing actual areas, right? Or volumes if they were in 3D, right? So let's go from lines to areas and figure out how to do area versus area so that we can actually have collision detection that is both numerically more robust because it's not talking about these infinitely thin things that are very easy to have epsilon issues around, A. And B, so that we can make the player have some volume as well, and so he will not be just a pinpoint that's moving around for the purposes of his collision detection. And so that's what we want to do. And ideally, we'd like to do that in a way that gives us a fair bit of flexibility with what these volumes actually are. I would like to basically say maybe at the very least, I'd probably say we might want to allow ellipses in there, right? Because I feel like the guy is probably wants to be an ellipse. I don't know. Maybe he wants to be a circle. I don't know. It's kind of hard to say. It depends on what's going to feel good to move around, really, right? But I don't know if a circle makes some sense for him or if an ellipse makes more sense. The problem is, the perspective of the game is a little tilted in that sense. And so maybe it needs to be more of an ellipse to properly feel right in terms of when you're moving through stuff. But at the same time, that means that your motion is going to feel different depending on whether you're grinding against a vertical or a horizontal wall when you turn the edge and stuff. So I don't know, maybe it's a circle. So at the very least, a circle. At the very least, we need circles because he's at least going to be probably a circle because you want him to kind of be smooth and to be able to roll around things so that when you're pushing into things, you don't want him to have you don't want his collision shape to have hard edges because they'll get caught in stuff and be kind of janky to move around. So a circle is kind of nice because it rolls off things and it just feels nice and smooth to move around. So we definitely want circles. And then we probably also want rectangles because there's probably going to be rectangle stuff in the game. But we might also want polygons, right? We might want to be able to say, let's be able to draw just arbitrary kind of little fancy sorts of things, perhaps, right? So that's another thing that we might want to have. And so we're going to want to basically think about when we upgrade our collision here now, we're going to want to think about how we can do something more along these lines. So what we might do is just do circle and square so that we can do tile map. Well, we could even just do circles and circles. Let's do circle and square. Let's shoot for doing circle and square now. But to think about also polygons going forwards, because when we actually go to do the real shipping collision detector code, whenever we decide to do that, it'd be nice to potentially have those. I'm not sure. I'm not sure if we'll want them, but we might. So we want to basically set our engine up, since that's, we're still in the phase where we want to define all the things we need to do and get, placeholder versions of all of them. I think that's basically what we're looking at. We're looking at circles, squares, and these. And maybe, I don't know if we want rounded rectangles as well. I don't know. We might like rounded, things that are kind of rounded as well. I'm not sure. We will see. But circles and squares will probably be our target for now. So we'll try to do a circles and squares one, and then we'll go from there. I think that pretty much brings us to the end of the stream. It's a short stream a little bit today because we were chatting a little too much at the beginning. Everyone was gabbing. But that's a good place to stop anyway, because tomorrow we can write the new collision detector. And so that'll be kind of nice to have the explanation and the implementation in one day, or at least the start of the implementation in one day. Okay, so let's go to the questions now. I will start the little thing here. So please, if you have questions, put a Q colon in front of them, and try to keep them things we've done on today's stream or on previous streams. If you want to ask off-topic questions, come about 15 minutes before the scheduled start time, and I take off-topic questions then. I don't take off-topic questions now. Can you change the whiteboard color to black and use a light-colored pencil color? Switching from Emacs to the whiteboard is jarring. It's true that that's not really the same color scheme as... It's definitely different. I don't know how that would look exactly. I guess we would do something. Does this have a universal eyedropper? Well, we could do something like this. Where is my color cop? There's my color cop. We could do something like this, where we grab out, whatever this color is. Let's see there. There we go. So we grab out that color. And we could say, okay, the color here Do you have, how do I just input a color, people? Where is that at? I don't want an advanced color selector. I just want a color selector. How do I just type in a color value? Seriously? Is this where we're at here? You won't let me type in a color, will you? All right. Never mind. Then I have no idea. Like, where are the colors? Is these the colors? There they are. Okay. So if I want to add this in, it's 205, 170, 125, and we'll make that be our foreground color, and then our background color is that. So that's 22, 22, 22. So there we go. And so that would look something like this. We could do that. We'll let you guys think about that. You can think it over. Would you give a tutorial for Emacs? There already is one. Take a look at the episode guide on if you go to handmadehero.org, if you click on the news and forums link, there's an episode guide on there, and there already is a tutorial for Emacs. Do you plan on getting into using calculus to get better collision detection? Or is that too... you don't really need calculus to get better collision detection. We'll be doing better collision detection. We'll be doing basically perfect collision detection. I mean, perfect is a tough word to use, but we'll be doing collision detection that is as shippable as any collision detection that ships in a game, but without really doing any calculus at all. So you do need calculus for some things, but just not that. Do you ever feel it necessary to prototype different aspects of your game, like collision detection with different methods in other languages, or do you always do everything in the language that you're writing the game in? I always do it in the language I'm writing the game in. Wow, everyone is in favor of the colors? Unanimously? That's crazy. Wow. Zoinks. If we change the resolution on Win3 to Handmade, will the tiles in the bitmap still draw the same but smaller, bigger versions of them with the same settings? So right now, we don't have any bitmap scaling code, so the bitmaps always draw pixel to pixel. So if you change the resolution, they'll change size. And that is one good reason, for example, why we would want our, or potentially at least, want our renderer to be able to handle things like that, at least in the final stages, where it could blow the bitmap out to a bigger size so it always, so it's not dependent on the resolution and so on. Can you do collision detection based on if a pixel in a bitmap has alpha? Yeah, you can, but you can't do it continuously. I mean, you sort of could do it continuously, but you can't really do it very efficiently with non-tunneling based stuff. So you try not to do that if you can avoid it. Like basically, the problem is, and we'll use the new colors. So what the problem is analytically, like we already did this even just in our simple one, right? We were able to take a time step from here to here and figure out whether we hit the wall at any time during that time step, right? There's no way to do that if we have to check the pixels of the bitmap. And the reason for that is because that creates some kind of that would basically create tons of little moving rectangles, right? That are all the rectangles that are set in the bitmap. And we'd have to check it that way to really do that full thing. And so what you would do if you were going to do that, right, is you wouldn't want to do it that way yet, right? What you'd want to do is take a look at the bitmap, and let's say that this is the bitmap that we're talking about. So for some reason, don't ask me why, it looks like this, right? What you wouldn't want to do is actually take all of the things that have alpha set and actually test all of those swept things versus every other swept thing. I mean, it would be a nightmare, right? What you would want to do, first of all, is you'd want to say, well, this guy, for the motion direction we're going, is always going to be behind this guy, right? And this guy is always going to be behind these guys, right? So I don't need to sweep anything but the exterior of the thing, and I only need to sweep the exterior in the direction that we're going. And quickly what you would find when you started to work on this is that, well, it would really just be way more efficient that no matter what, crazy thing my guy looks like, right? Like he's some snowman weird thing or whatever. What I'd really rather do is just put some polygons in here that very closely approximate the dude, right? And then just use the edges of the polygons instead of using each individual pixel, because otherwise you're just going to drown in computation. And this is basically as good because it can be pretty close, and you can always make the polygon pretty detailed if you need it to be. But at least then you're only checking, like you're checking some version of it that's not literally looking at every little pixel, because that's just going to be way too slow if you actually don't want to tunnel. Is it interesting to have a tutorial on floating point peculiarities? Probably it would be, but I'm not the guy to give it. Like basically I'm not super knowledgeable about floating point computation. Like I'm passable at it, but I'm just not, I wouldn't give a very good tutorial. Like basically the way you see me working around it on the stream will be basically all that I know is really how to do, So we'll cover it when I do workarounds for stuff, but I don't really know, I'm not very good at that. So I'm the wrong guy to give that tutorial. I missed parts of this stream, but in the last episode you added the new collision system and removed the old one. Why not use the old one and just use the new FT thing to get the new point if and only if the old system detected collision? Because I want to move to a system that's actually not using the tile map anymore eventually, right? I want to basically do an object-based collision system. So we're going to have stuff like, I think our tile map will basically have a bunch of stuff in it like, trees with little collision volumes at the bases of them or whatever. And I want to collide against those potentially. Like, I don't know what I'm going to want to do, but I don't want to actually do tile map based collision. I want to just do like polygonal and circular based collision so that I have more flexibility with what the maps look like. And so I'm not really interested in using the old version. So I think, wow, not many questions today, it looks like. Oh, and what about the tiles? Will they still draw the same across the screen with a different resolution? For example, we have 9 by 17 tiles across, and if we switch the resolution, that would be like 17 by 9 tile-based. Will we have any bugs and how to fix that? So I'm not sure exactly what you're asking, but basically the idea is the game screen will always be the same. And so right now we don't have the ability to, okay, we'll talk about two things. So first of all, we're a bitmapped game. So we probably want to run in our native resolution most of the time. So we probably want to run in 1920 by 1080 all the time, right? That's probably what we will do. And so what we'll probably do is we'll draw in 1920 by 1080. And we might also support downscaling by 2. So we might also support running in a half mode where we're running half of that, and where we actually have our bitmaps pre-processed so that they're all half size. And that would be to support like Raspberry Pi and stuff if it's too slow. Or actually more to the point for the Raspberry Pi, too little memory potentially as well. So basically what we will do is we will have a 1920 by 1080 buffer where our tiles are lined up the way that we want them, right? We will draw to it, and then no matter what the ending resolution is, we will blit that up to that resolution, right? Because we don't want to resize every individual thing, because that just wastes a lot of time and will look worse than if we just actually do the whole composite and then scale it up at the end, or down, depending on the circumstance, right? What is dynamic loading? I thought C was compiled and needed to be recompiled to update the code. No, I mean, C is a compiled language, but that doesn't mean that you have to not have dynamic loading. So we just implemented dynamic loading. You can go back and watch it, the episode where I implemented that. We basically just implemented a system where you can recompile without exiting the game. So yeah. Any more on-topic questions? Does anyone have any more on-topic questions? I'm guessing the answer is no. I'm guessing that the answer is no. And it looks like it's true. There are no more questions. Although I don't know how long the lag is. When I say, are there any more questions? I don't know when you guys actually hear the fact that I just said, I don't know if there are any more questions. Like, it could be 30 seconds. It could be a minute. I have no idea. But yeah. All right. Well, then I guess we all get to go home early today. That's some seriously, I'm going to go make some more tea. That's what I'm going to do. So I certainly hope that all of you will think about collision detection and dream about collision detection while you're, sleeping tonight, and what we're going to do tomorrow. And so we'll come back tomorrow, and we will write. Oh wait, I don't want to actually delete this. I'm going to leave it here. Can I save? Now that we've made our settings here, can I save that setting at all? I don't know if we can save like our foreground and background color. Let's do a save as, and I'll just make a desktop thing that's like handmade hero.kra. Let's find out. You ready for this? You guys ready? I don't know if you are or not, but I'm doing it anyway. Wait for it. Wait for it. And nope. The answer is no. So that's a little bit a letdown. It was exciting for a minute. It's true. But then it all went to pieces. So I guess what we're going to have to do, apparently, is we're going to have to do that. And then we're going to have to do, where's my color cop? We're going to have to do the old, let's see. We're going to have to do the old color swatch up in the corner trick. All right. And then we'll save it. And then I'll grab it from there when we reload. Thanks, Krita, for not saving anything with the file. You certainly wouldn't want your foreground and background colors persist. All right, everyone. Thank you very much for joining me for another episode of Handmade Hero. We have gotten to the end of our crappy collision detection. And so tomorrow it's time to start on some good collision detection. I certainly hope you'll join me. Same time, same place, 8 p.m. Pacific Standard Time, right here on Twitch. And we will be talking, among other things, about our friend Minkowski and why you should get to know him, because he makes your collision detection life much, much easier than it would otherwise be. If you want to follow along at home and you have not already pre-ordered the game, you can pre-order the game on handmadehero.org and get all the source code. That is a good thing to have if you want to play around at home. You can do that right here. If you want to support the video series, you can go to our Patreon page, which is linked to here. If you want to learn about the series, you can go to our resources page, news and forums, all kinds of good stuff, schedule, episode guide to catch up on past episodes, coding resources, which has ports to Mac and Linux and stuff like that, and code discussion where you can ask questions, like a nice little forum you can go to and check it out. So, okay, that is about it. I highly recommend checking out all that fun stuff. In the meantime, have an excellent Thursday, and I will see you tomorrow night. Thanks, everyone.